starting today, what is called triangle congruence. If you have two triangles, there's 5 ways that we can have congruence. In other words, they're the same shape. So we don't have to measure everything. If we want to prove that 2 triangles are congruent, there's 5 ways we can do that. All right, we've already had the first way. If we have a right triangle and we have a leg and a hypotenuse congruent, these 2 triangles are now congruent. All we have to do to prove 2 right triangles are congruent is by measuring the hypotenuse in one leg. If we measure the hypotenuse in one leg of 2 right triangles and they're the same, these are congruent. And that's called the HL congruence. If we have 2 right triangles, all we need to measure to prove congruence is the hypotenuse in a leg. And then the other 4 ways involve either sides or angles. And so the letters that you see are the order of the sides and angles. So if we have 2 triangles and we measure the 3 sides, these 2 triangles are congruent if all 3 sides are the same. That's called SSS. If we have 2 triangles, all we have to do is measure the 3 sides to prove these 2 triangles are congruent. And that's called SSS. And that's helpful because we don't have to measure everything. We don't even need to know an angle to prove these triangles are congruent if the 3 sides are congruent. And that's what these 3 letters mean, SSS. The other 3 need at least one angle. So if you want to prove 2 triangles are congruent without measuring all the sides, you need at least one angle. Okay, so the second one, ASA, that means angle, side, angle. Notice angle, the side in between the other angle. So if you want to prove these 2 triangles are congruent, all you have to do is measure 2 angles and the side in between. And that'll prove these 2 triangles are congruent. And that's called ASA, which means angle, side, angle. Okay. The third one, angle, angle, side. And that just means you measure 2 angles and a side that's not in between. That's the difference between these 2. You're measuring 2 angles, but with AAS, angle, angle, side, the side is not in between. Whereas angle, side, angle, the side is in between. That's the difference. Okay, so again, these are very useful because if we want to prove triangles are congruent, we don't have to measure everything. We can get away with measuring only 3 things. Either all 3 sides, 2 angles with the side in between, or 2 angles with the side in between. And that's all we need to measure to prove these triangles are congruent. Okay, the last one, SAS, side, angle, side. That means the angles in between the 2 sides. So if we have 2 triangles and we want to prove they're congruent, all we have to do is measure 1 angle and the 2 adjacent sides. And that proves these triangles are congruent. That's why this is helpful, because we don't have to measure everything. Okay, and again, notice the order of these letters. That's why we use the letters S and A. The only one that's different than the other 4 is the one we started with a couple weeks ago. If we have 2 right triangles and a hypotenuse and a leg are the same, then the right triangles are congruent. Okay, so notice some combinations of letters are not one of the 5 methods. So there's 2 other combinations of letters that isn't up here. Does anybody think they know what combinations of the letters S and A are not one of the 5 choices? So we have 3 S's, we have an ASA, we have an AAS, and we have an SAS. So there's 2 other combinations that are not one of those choices. Okay, I'll wait a minute if anybody wants to submit a text in the chat or write down a choice. What other two combinations of the letters S and A are not one of these four choices?